So I would like to talk about e to the x first. So when we differentiate e to the x, we get e to the x times natural log e, but this is not required. Why? Because it is 1. But when we differentiate 5, let's say, to the x, or any number to the x, we have to write 5 to the x times natural log 5, which was not required here. Or in general, a to x times natural log a. Now if I have a to a function, then I have a to that function times the function prime times natural log a. So now we can look at this integral, which is the integral from 4 to t dt. So if I want to obtain this, then I have to have this in the denominator. So this will be 4 to t over natural log 4 plus a constant c. Remember, the indefinite integral is always friendly because I can check. The definite integral I can't. And let's say now you say, show me. Okay. When I differentiate an integral, I get the function. Let's see what we get here. When I differentiate 4 to t, I get 4 to t times natural log 4. 4 to t times natural log 4. The constant is in the denominator. I can change that, or I pull it in front. C prime is 0. So I get rid of these two because they are the same, and that's how I get the 4 to t. So I can always check, as long as it's a indefinite integral. Next question, please. I need 1 more second here. Because I sent to the copy center tons of stuff, and they did separate them. And I didn't have 1 second to separate them myself. Yes. Next question, please. Is this clear? Felix, is this okay, everyone? And you can always, always check. Always. When I brought this box today, the window student says, "Can you bring us donuts?" I'm so sorry. No, I didn't. It's just coming from the coffee center. I'm so sorry. I was very apologetic. Okay. So I would like us to look at this, and also I would like us to work on other problems as well. However, I'll start with whatever you want me to start with. This is 1, 2. I have 2 in there. So please tell me what you would like to start with.
Number 2.
Okay, we want to start with number 2. Okay, by now we should be very, very familiar with this one because I think we had like at least 4 or 5 problems like this. Yes, so we have f of x, 2x cubed plus 4x plus 8, and the interval is 0, 4, and we're asked to find the area using the limit of the Riemann sum. After we finish this problem, I would like us to jump to number 5, and then we'll come back to others. Okay, so you can start with determining the integral using the definite integral, if you'd like to have the heads up and find out what to expect. So you can. So the area is the integral from 0 to 4 from 2x cubed plus 4x plus 8 dx. So we do have 2x to the 4th over 4 plus 4x squared over 2 plus 8x from 0 to 4. Luckily, I don't have to plug in 0. So I have 1/2 4 to the 4th plus 2 times 16 plus 32. How much is 16 times 16? Is it 256? And I divide that by 2 and I get 128. Plus 32 plus 32, which is 64. So I get 192. So I'm hoping after I finish the limit of the Riemann sum, I get 192. For the limit of the Riemann sum, we need 3 preps. Yes. First prep, please. Very good. Delta x is the first prep. So how much is delta x? Prep number 1, delta x. Yes, 4 over n. Perfect. Prep number 2, xi. Luckily is started 0. 0 plus I delta x, which is 4i over n. And prep number 3, it has to be f of xi, which in this case is f of 4i over n. So I plug it in the function, ugly, 2 times 4 to the 3rd, I cubed over n cubed plus 4 times 4i over n and plus 8. Four to the 3rd is 64. 64 times 2 is 128. 128 I cubed over n cubed, 16i over n and plus 8. Please keep my numbers in check, right? 4 to the 3rd is 64, and 64 times 2 is 128. Okay. I have all pieces, remember? This is the limit of the Riemann sum. Let's write it one more time, so see it. Limit as n approaches infinity from the sum from I equals 1 through n, from the first subinterval, from the first rectangle till the last, from delta x f of xi. That's why I need to determine this first. Then I need to determine this. Then I need to determine this. And now I can put them together, but I would like to save some time. Here's what I do. Since delta x does not depend on I, I'm going to put it in front of between the limit and the summation notation. And delta x, as you told me, is 4 over n. So this is limit n approaches infinity from 4 over n. And now I have to write the sum of the first term plus the sum of the second term plus the sum of the third term. So if I want to, I don't have to. Please tell me whether you're not comfortable. If you're not comfortable, I'm going. So the sum of this brings 128 over n cubed, the sum of I cubed. And then plus 16 over n, the sum of I, plus 8, the sum of 1. So basically, if you agree with this, we did 3 steps in 1. What did I do? I took delta x in front of the summation notation, and then I already applied the sum to each term. And also, I took 128 over n cubed in front, I took 16 over n in front, and I took 8 in front. Because these are identities that I know. So I replace this piece by n, this piece by n plus 1 over 2, and this piece by the same thing but squared, n squared, n plus 1 squared over 4. Is this okay? Is that a yes? Is that a maybe? Yes? Okay. So now I have some simplification to do. I have to find the least common denominator, eventually multiply by 4 over n, and then find the limit. So let's see what we can do. Limit n approaches infinity 4 over n. 128 over n cubed times n squared. I'm going to square this. N squared plus 2n plus 1 over 4 plus 16 over n plus 1 over 2 plus 8n. So in the next step, I had no choice. I had to replace each and every summation or sigma notation by whatever it equals to. And I realized that the denominators, other than n, all quantities will go away. The n squared with n cubed, I still have an n, but 4 will simplify with 128. I still have an n, but 2 will simplify with 16. So the least common denominator is nice, just n. Everything else goes away. Limit n approaches infinity 4 over n. Careful, let's simplify. 2 from here with 2 from here. 4 from here with 32 from here. 2 from here with 8. So now the least common denominator is simply n. So 32 gets distributed to n squared. Of course, there is a 4 in front, but I have it. So 32n squared plus 64n plus 32 plus 8n squared plus 8n. And this one gets an n plus 8n squared. Let's do this one more time together, okay? So I distributed 32 to n squared, to n, and to 1. So 32n squared plus 64n plus 32. Then I have 8n to be distributed to, because I can't simplify, I still have an n. I still need an n in the denominator. 8n squared plus 8n. But this one has denominator of 1, so it has to be multiplied by n, and I get 8n squared. At this point, I will rearrange everything in descending order. So this is limit n approaches infinity. 4 is outside, can wait patiently. 8 plus 8 is 16. 16 plus 32 is 48. The 64 plus 8 is 72, and plus 32. Yes, you too, thank you. So we multiply basically 4 by 48. And what was the answer we got? Because that should be it. 2 and 3, yes. Now let's say you may not see where this is going, which is fine, but you realize that this is infinity over infinity, and we can apply L'Hopital's rule. So we have limit n approaches infinity from 40 is outside. I don't care for it. It goes outside. So 48n squared. So this will be 96n plus. Sorry. There is an x in here, please. So there is an n in here, n, and then 2n. You know what I mean. I'm sorry. So it's 7. And then when we differentiate again, we will get 96 over 2 with 4 in front. So it doesn't matter when. Yes, you're right. Doesn't matter when I differentiate again 72. Yes, but you're right. Thank you. My apologies for that. So then we get 192. Thank you. Yes. Any questions? Any questions? Okay, I would like us to continue. Do you want to continue with anything specific, or I would like to, or I can choose, and you can choose the next one. Okay, I would like us to determine this. So there are many problems in which we will not be able to determine the antiderivative. You will not be able to find the antiderivative of e to x squared. You can't. I can't. No one can. We need a computer for that, a software, like Mathematica or Maple or other math lab. Okay. But we can still come up with some approximation. It's a definite integral. The result must be a number. We can still come up with an approximation. And here's how we're going to do this. We had a problem like that some time ago. So the integral is the integral from 0 to 16 from e to x squared dx. Midpoint rule with 4 subintervals. From 0 to 16, 4 subintervals, 4, 8, 12. The midpoint is 2, is 6, is 10, and is 14. So this is approximately, no way exact, right, is delta x times f of 2 plus f of 6 plus f of 10 plus f of 14. Delta x is the width of each of the 4 subintervals, which is 4. That's why the constant goes outside. So then I have 4 outside. And then I'm going to find e raised to the 4th power plus e raised to 36, which is huge. E to 64 plus, 4, 36, 100. And e to the 14th squared. I am fine with this. Because if you plug them in the calculator, you're going to see it's a big number. Okay, 4. Quantity. E to the 4th power plus e to the 36, because that was 6 squared, plus e to 100. That's huge. And then plus e to 14 squared. Oh, 5.2 times 10 to the 85th power. 5.29 times 10 to 85th. The technique is important, not the number, of course. Okay?
Can we do it in left and right this way and left and right the graph?
Say it again.
Can we do like a left and right this way? Or if we can decide?
You don't have to show the graph, but you have to use the midpoint. Not the left, not the right, but the midpoint. That's why we pick the midpoint of each subinterval. So we are not using 0 and 4. We are using the midpoint.
You're talking about like a left and right.
Yes, then you will write 4 times f of 0 plus f of 4 plus f of 8 plus f of 16 for the leftmost point. Now, if you want the other one, then you will have 4 multiplied by f of 4 plus f of 8 plus f of 12 plus f of 16. But these will not be, either one of them will not be the best approximation. The midpoint will always be the best. Very good. Is that clear? Perfect. Good. Next question. What would you like to continue with? And put it in the attendance in, so I don't forget. Because if I do, I get an email message.
Can we get 6 just to go with the total distance?
Yes, of course. Okay, number 6. Where is it?
Yeah,
4, 5, 6. Yes. So we're given the velocity, and we're asked to find the total distance between 0 and 10. Excellent. So the velocity, v of t, so this is nice. It's not a quadratic function, 3t minus 12, and the interval is 0 to 10. So you may be asked to find the displacement. So let's find the displacement first. So s of 10 minus s of 0 is the displacement, which is, of course, the integral from 0 to 10 from 3t minus 12 dt. So this will be 3t squared over 2 minus 12t from 0 to 10. Lucky me, I only need to plug in 10. So 100 divided by 2 minus 120. So it's 3 times 50, 150, minus 120 equals 30, which means the particle moves 30 units in the positive direction. Now, when I'm asked to find the total distance, it's a total distance, different story. Total distance is the integral from 0 to 10, but from the absolute value of 3t minus 12. And this will give us the total distance covered by the particle, regardless in which direction it's going. It will accumulate distance no matter which direction it's going. Luckily, 3t minus 12, as I said, it's a linear function. We have to use the absolute value, 3t minus 12. And we know there are two options. What are the options for the absolute value? Yes, one option is 3t minus 12 if 3t minus 12 is positive or 0. And the other option is negative 3 plus 12, 3t plus 12 if 3t minus 12 is less than 0. Remember, we never solve this one. Do not waste your time. You may even make an error. So the simplified form is 3t minus 12 for t greater than or equal to 4, and negative 3t plus 12 for t less than 4. If the first one is greater than or equal to 4, the other one must be less than 4. That obviously gives us two integrals. Of course, dt and dt. So remember, the integral was from 0 to 10. And we have to break it up where? At Move 12 divided by 3. We have to solve that for t. Good. So then what we have, zero to, of course, and 4 to 10. Of course, that's where the breakup is, right at 4. So now we have to be very careful and put the correct function in between 0 and 4. Which function is here? Yes, negative 3t plus 12. And which function, of course, it must be the other one. Be very careful how you create this sum of two integrals. They have to be the correct ones, right? On the intervals that we are given. Okay, so then negative 3t squared over 2 plus 12t. This one is from 0 to 4. And the other one is 3t squared over 2 minus 12t. And this one is from 4 to 10. So what do we get as answer here? This is not a friendly situation because it's cumbersome to plug in these numbers. Yeah, we have calculators, but still it's not. Luckily, there is a 0 in there, so I only have to plug in 4. So negative 3, 16 divided by 2, plus 48. And then I don't have to worry about the 0. But then plus 3 halves times 100 minus 120 and minus, sorry about that. So 16 divided by 2, 8. So it's 24 and minus 48. So this is negative 24, this one, plus 48, and this one plus 150 minus 120. And this is negative 24, so plus 24 in front. Okay, so these two go away. 150 minus 120 is 30, and 30 plus 48, I got 78. So the total distance back and forth covered by this particle is 78. Next problem, next topic, anything you'd like to go back to? Which one? Yes, of course. Which number? This one. Okay, very good. Okay, so we have f of x equals 4 e to the x minus 7 hyperbolic cosine x, and they're asking us to find the antiderivative. Since the function is given as lowercase f, the antiderivative has to be denoted by uppercase f, as we discussed a long time ago. Okay, good. So which function prime is 4 e to the x? Yes, 4 e to the x minus 7. Which function prime is cosine? Hyperbolic cosine. Hyperbolic sine. Plus, which function prime is 0? So this is the most general antiderivative. Are we given any conditions? No. So this is it. Very good. Anything else? Number 8. 4, 5, 6, 7, 8. Yes. Very good. Number 8 it is. The integral from natural log x. So this is the function, of course, given in the form of the integral. So 2x squared from sine squared t dt. Okay, so we are only asked to find f prime. We're not asked to do anything else, and we can't do anything else. Just differentiate this, but it's not ready. So first we have to split it up from natural log to whatever you want, plus from the same number to 2x squared. This is good, but it's not good enough. Remember the fundamental thing about calculus part 1. Let me refresh your memory. Let me write it here. It says that if we have a function like this, from a constant to x from f of t dt, when we differentiate this side and differentiate this side, we get f of x. It only shows that when I differentiate an integral, I get the function. Now, if this happens to be, it should be times x prime, but we don't write it because it's 1. But if this happens to be a function, when I replace t by that function, I have to differentiate that function. I shouldn't use f. Let me use h. So if this function happens to be h of x, not plain x, then I have to multiply by h prime of x. If it's plain x, I don't have to. But if it's not plain x, I have to. Okay, so I have this integral in the correct form, but I don't have that integral in the correct form. So what should I do? Yes, correct. And then it's ready for differentiation. So f of x equals the opposite from the number to natural log x. If this confuses you, just put anything you want. Put 5, put 10, put 0, put whatever you want. Sine squared t dt plus the integral from that number to 2x squared sine squared t dt. Now, both integrals are ready. I differentiate the left-hand side, I differentiate the right-hand side, and I get f prime equals. I replace, remember, when we differentiate an integral, we get the function, but this is a function, so I have to replace t by that, sine squared of natural log, but I have to differentiate by log prime, which is 1 over x. Plus, I plug in t, I plug in 2x squared. I said and I didn't do it, okay? But I have to, since this is not plain x, I have to multiply by 4x. 2 times 2x. You don't have to do anything else. This is good enough. If you want to rearrange and put 4x in front, that's good. Other than that, it's done. Okay, my turn to choose a problem. Okay, so I like to look at something like this. Okay, I'm looking at 14. The speedometer readings for a motorcycle at 12-second intervals are given in the table. 0, 12, 24, 36, 48, 60. Estimated distance traveled by the motorcycle during this time period. We did this last time, right? But we can be given a table. So estimate the distance traveled by the motorcycle during this time period, because we have the table now, which we didn't have there. And we don't have the function, but we have the table. Using the velocity at the beginning of the time intervals. Give another estimate using the velocity at the end of the time interval, of the time periods. Are your estimates in part A and B upper and lower estimates? Okay, ready? So I'm going to copy the table. They want the leftmost point first, and then the rightmost point. I'm sure you've seen a problem like this in WebAssign, right? Yes? Okay. So this is problem 14 on page 370, and the table time in seconds. I need to copy it so I don't have to go back to the book. The velocity, of course, in feet per second. 0, 30, 12, 28, 24, 25, 36, 22, 48, 24, and 60, and 27. Okay, so estimated distance traveled by the motorcycle during the time period using the velocities at the beginning, so the leftmost point, and then the rightmost point at the end of the interval. So if you plot these points, you will understand, you will see that we only have to determine the area under the graph of velocity, which will be the distance. So S of t with the leftmost point. That would be, what is the width of each subinterval? 12. So each and every number will be multiplied by 12. So we want the leftmost point. F of 0 plus F, I should write V. So let me write V. That's the velocity, of course. It's a function, but I don't want to confuse you. I want to use the notation I see here. So it's V. So V of 0 plus V of 12 plus V of 24 plus V of 36 plus V of 48. So this interval, leftmost point, this interval, leftmost point, this interval, leftmost point, this interval, leftmost point, this interval, leftmost point. Okay. So all I have to do is just punch in the numbers. 12 times 30 plus 28 plus 25 plus 22 plus 24. So please give me the number. So this is the distance covered by the motorcycle between 0 and 60 seconds. Estimated distance using the leftmost point. So whatever number you give me, I'm going to trust you and put it in. Now we want to determine the same thing, but with the rightmost point. Still 12, but this time where do I start and where do I end with the rightmost point? V of, exactly, plus V of 24, plus V of 36, plus V of 48, plus V of, indeed. So then I'll wait for you to give me the number. So this time is 28, plus 25, plus 22, plus 24, and plus 27. Yes, one of them will be an overestimate, and the other one will be an underestimate. We can determine the midpoint because we do not have the heights or the function value in the middle of the interval at 6. We don't have the function at 6 or 18 or 30 and so on and so forth. So what do we get for the first one? What was it? How much? 1806. And what about the other one? I'm not lazy. 28 plus 25 plus 22 plus 24 plus 27. I got 1512. This is the lower, this is the underestimate, and this is the overestimate. So we know for sure that the distance is definitely between 1512 and 1806. Very good. Next question, please. Anything else you would like to? If not, I will choose.
About 15. Yeah, 28.
Yes? Okay, it's very possible. Let me check. So 12, 28, 25, 22, 24, 27. Did I copy something else?
For the first one.
Oh, for the first one. Oh, I don't know. I didn't calculate that one. So 12, 30, plus 28, plus 25, plus 22, plus 24. 1548. We agree with 1548? Yes. Sorry. Yeah, it was kind of too wide of a range. Thank you. Thank you for checking that. Okay, so then 1548. Much better. Good, thank you. Good. Next problem. Anything else? I'd like to look at a problem like this. I need my pencil. Ready? So in this problem, we are asked to the graph of G consists of two straight lines and a semicircle. Use it to evaluate each integral. Please choose an integral. A, B, or C? Which one? B. Very good. So between 2 and 6, so this is 2 and this is 6. Too easy. So it's this area. Since it's below the x-axis, it must be negative. Very good. So the radius is 2. So this will be a complete circle, but it's only half of it. And the radius is 2. So it's going to be pi r squared. Pi r squared divided by 2. So it's 4 divided by 2, so this is 2 pi. This area is 2 pi. Any questions? Say it again. Of course, yes. I just said negative, of course. Sorry. Please, of course. Sorry, my apologies. Negative 2 pi.
So the other one should just like count the boxes.
Yes, it depends. So let's choose another.
Maybe just say
You want to determine C? Yes? C is the integral from 0 to 7. So the whole thing. Good. So we already know that this one is negative 4 pi. Agreed? Was what? I'm sorry, I just erased. Negative 2 pi, yes. Good. So now I have to determine this 1 by 1. Base times height divided by 2. So this is plus 1/2. And this one is base times height divided by 2. 2 times 4 is 8 divided by 2 is plus 4. So the area will be negative 2 pi plus 9 over 2. Any questions about that? Is this okay? Good. The areas above are positive and the area below negative. Good. Next question, please. What would you like to continue with?
Can we do the extra credit?
Yes. Let's look at the extra credit. What does it say? Yes. Very good. So 3x to the fourth minus 18. They say it's the integral from 2 to x from f of t dt. The function f of x satisfies the equation. Find the function. Sorry about that. So 3x to the fourth minus 18 equals the integral from 2 to x of f of t dt. What can we ever be asked about the right-hand side? There's only one thing we can be asked about the right-hand side to do with it. What is that thing? Differentiate, of course. There's nothing else. It's a function given as an integral. The only thing we can be asked to do with it is to differentiate it. And that's the only way we can find the function. So what do we have on the right-hand side then? Say it again. Which one? The left-hand side is indeed 12x cubed, but what about the right-hand side? We just did a problem like this a few minutes ago. So what do I write when I differentiate this? Indeed. That's it. That's the function. When I differentiate an integral, I get the function. Now, if I had here, for example, 2x, I would have had to write f of twice x times 2. But then another condition must be given so I can find f of x, not f of twice x, right? So if I have, for example, here x to the third, then this will be x to the third times 3x squared. But then another condition has to be given to us, or some information about f of x cubed in order to find f of x. Is this clear? Good. Next question. Let's look at problem 7. So the integral from 0 to 1 from x squared sine x dx, unless we have already worked on this. Have we? We have? We have? Okay, that's fine. Even if we did, it's a good practice. Okay. We cannot, at this point in time, till Calc 2, we are not able to integrate x squared sine x. You will be in the next class. I begged for Calc 2, and I didn't get it in my regular schedule. I may, if it runs, I may have one online, but I don't know yet. Okay, so we're not asked to find the integral on the left. We're asked to show that the left is less than or equal to 1. Where is our starting point? Say it again. Excellent. That's the starting point. It means that I tortured you enough. You started remembering things. Well done. Indeed, that's all I know for now. Okay. When we talk about sine, and x is between 0 and 1, means between 0 radians and 1 radian. So I'm trying to build this function. And I know that x is between 0 radians and 1 radian. And I know that sine is an increasing function or a decreasing function between 0 and 1 radian. 1 radian is roughly 60 degrees, it's less, it's 57 degrees. So it's increasing. Good. So because it's increasing, So this is at pi over 2, and this is at 1 radian. The function is increasing, that I don't have to switch the inequality symbols. I apply sine. Okay, as you see, the integral does not have the left-hand side, so I'm going to drop this side. There's nothing wrong with it, but I don't need it. So this is 0, but I don't need it. Okay, so I have that sine x is less than or equal to sine 1. So I managed to build this piece right here. But I'm not done building the function. What should I do now? Because I need that x squared in front. Multiply both sides by x squared. It cannot be 0. It's at the end of the interval, so that's fine. So it cannot be 0, it has to be positive, because otherwise I have to switch the inequality symbols. So I'm multiplying both sides by x squared, and I get x squared sine x less than or equal to x squared sine 1. I built a function. In other words, I'm saying now that this function is smaller than this function on the interval 0 to 1. Then there is a property of the definite integral that says immediately that the integral from this must be smaller than or equal to the integral from this. So I'm allowed to do this. Do not forget the x. It means nothing without the x. From 0 to 1, from 0 to 1. This is a property of the definite integral. So therefore, the left-hand side is done. But now I have to work on this. Is sine 1 less than 1? Yes. Sine 1 is less than 1. Sine 1 is this piece. Sine pi over 2, which is 1, is this piece. So this is much smaller. Not much, but smaller than sine 1. So then I'll have to say that x squared sine 1, not here, here. X squared sine 1 is definitely less than or equal to x squared. So I'll say less than or equal to x squared, 0 to 1 dx. And I don't need the sine 1 anymore, dx. From 0 to 1. But this I can calculate. It's x to the third over 3 from 0 to 1, which is 1/3. That's all I needed. I'm saying that all this integral is less than 1/3. If it's less than 1/3, is it less than 1? Therefore, it is less than 1.